right. In case you didn't overhear,
Did you start recording?
I did.
Okay, it's blocking that one.
No, because the camera's on that side.
Okay, somebody was saying, texting that they can't see.
The Zoom's on.
Okay, is it? Yeah, it seems like.
No,
Okay.
you did.
All right. Just before Aubrey gets started, I just want to make sure she's going to go from 4 to maybe like 4:40, 4:55. We're going to take a 5 minutes break, then 5 to 6 I'll be here. So, but once the class starts till 6 o'clock, we expect you to keep your phones completely put away and make sure that you guys interact with her, ask questions, and we do not definitely want to waste time. We're going to get started right away. Sounds good? All right? Did you turn this off?
I did.
Okay, all right.
Good luck, guys.
So, my name's Aubrey. This is my, I think, third year teaching this. It's, I've taught geometry for the past 3 years and then just switched into Algebra 2 this year. So that's a little bit about me. You're aware that the ACT is changing. So for those of you who have never taken it before, start fresh, learn new. But if you have taken it before, we are getting less questions, which is good, and just a little bit more than 1 minute per question, which has always been that rush, 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 rush. And so we're still trying to answer questions as clearly and as quickly as we can, but it's eased off just a little bit. The other thing that I like about the change is that there's going to be, I want to say 50 questions? No, it's 50 minutes. I don't want to tell you wrong, I'm still, okay, 45 questions, 41 scored, 50 minutes. So lots of different numbers to keep track of. I like the fact that 4 aren't going to be scored because it's very rare, but I've taken a lot of tests in practice for this, and one time there was a test and there was one question and my brain got stuck on, that's not possible. That's wrong. They were treating a trapezoid problem like a triangle problem, and they're not proportional the same way, and so my brain just got stuck on, that's not right. And so I had to like force myself to just leave it alone, move on, rather than get stuck of, well, I want to argue with this question, because that's a complete waste of your time. If there's something that's like, just, that doesn't make sense, it's better to cut your losses and move on. Now is not the time to argue with the question. And I did later post it online into a teacher forum and had somebody who was writing for the ACT, and they're like, yeah, that was a bad question. And so they do happen. I've taken about 20 tests, and that was one question on one test. And so now if I knew, oh, they're going to be having experimental questions mixed in the mix, I would look at that and go, oh, they probably haven't caught the flaw yet, and I could just move on a lot easier. And so mentally for me, the fact that there's these buffer questions, it helps to decrease some of that pressure of I've got to get everything. And so that's a really good mental space to be in. I don't think it's, I just grabbed this book and because I couldn't remember which class had which, but in it, and I think similar to yours, there's a list of the math topics that we're going over and also like the individual categories. So I'm going to be using that as a guide today for what you might see, and we're going to be talking about geometry. So if you have the little spiral bound thing, we're going to be sticking within the first 3 pages. That's kind of where the geometry stuff is if you want it for reference. So the first thing, the bullet says, estimate the length of a line segment based on other lengths in a geometric figure. And so I've never seen a particular ACT question that asks that thing. But the ability to estimate and say whether an answer makes sense or not is a huge benefit to you. It kind of just tells you, I'm in the right ballpark. And so your brain, if it can do that naturally and be comfortable with this answer makes sense, this answer doesn't make sense, it's a huge confidence boost. what I do see in the next bullet point is calculate the length of a line based on the lengths of other line segments that go in the same direction. For example, overlapping line segments and parallel sides of polygons with only right angles. And so the one that I have right here, I'm showing online just a little bit, but I'm going to draw it up here, that we have this kind of modified L shape. And they tell us 3, 2, 1, and 4. And one of the things that you get is in the ACT, if you've taken geometry, you're trained to never take things under assumption. You have to be told. In the ACT, if it looks like a right angle, you get to treat it like a right angle unless they tell you different. And so we get to assume this is a right angle figure, which is nice. And so the question is, what is the perimeter in total inches of the figure? So the question I will always be asking is, well, what is the answer? But more importantly, how is your brain trying to find this answer? Are you looking for missing pieces? What are you doing? Yeah.
Like, you're gonna, based on the numbers and, like, you're gonna add them to make the bigger segment. Like, for example, the bottom side is 4,
Mm-hmm.
and you know the top side is 3.
Mm-hmm.
So then the other side that can be added to the 3 is 1, which
Yeah,
makes 4.
you've got to make up the difference to get the complete side. And for this other one, kind of the reverse. Now you have the 2 pieces, you get the whole thing. This side is 3, and then you have to add up all the pieces. So that's one technique. But these ones show up often enough, I'm going to talk to you about the shortcut. Because again, even though we've got a teeny tiny little bit more time, we're still interested in getting answers as quick as we can. This is going to be a rearrangement thing. Because we knew that it had to be 4 all the way across, right? That's where you got and you took the 3 and you took it away and you had 1 left over. You don't have to find that 1. You have to know it's 4 across. And so it is 4 here and also 4 here. We know that it is 3 over here and then it's 3 over there. And so all you have to do is 3 plus 4 plus 3 plus 4. You don't really need all of those other numbers. And so this one, really common problem. I've got this one, little bit different, because now we have 14, 5, 2, 4, 3, 4, 4. But try and rearrange it. All of these pieces, this 2, this side, this 4, this 4, all of them are going to be the same as 14. And so you don't have to waste the time looking for, well, what is this piece? Because if you're looking at perimeter, you just want to know that that's 14. And the same way, 3, 4, 5, okay, 7 plus 5 is 12. And the same way, this is just gonna move over. We could figure out what it is, but you're aiming for the answer they asked for. You're aiming for perimeter, it's just 12. You don't have to do that intermediate solving, because all you're gonna do is turn around and use that to find out the number that you already knew, the big one. And so with that perimeter, as long as you can say, okay, move the pieces, turn it into a big block. And they like this one. It made their list. They really like these perimeter of these kind of right angle L goofy shapes. So next one is perform common conversions of money and of length, weight, mass, time within a measurement system. You've probably done that in your science class more than in a math class. And I'll admit, we might get to it in another section, but I haven't seen it a whole lot on the ACT. So we're gonna focus on the big ones today, and then we're gonna come back to some of the more detailed ones later. So, compute area and perimeter of triangles, rectangles, and other polygons. So we're gonna take a minute to talk about this, because unlike the other standardized tests that you've done, there is no formula sheet on the ACT. You've got to know all the formulas. And so I'm going to show you how you can know those formulas without trying to memorize them, if that makes sense. So you do have to memorize one. What's the area of a rectangle? Yeah.
Length times width.
Yeah. So, in the next shape, a triangle, the most basic one is when you've got a right triangle. How does that compare to a rectangle?
There's a length and a width.
There's a length and a width. But compared to the rectangle, how much do we have of it?
Half.
We've got half. And so a triangle is literally 1/2 of length times width, frequently changed to base times height. And this holds true for any rectangle, or for any triangle. If we've got a triangle that looks like this, it's still half of the big rectangle. And so it's, I prefer writing divide by 2 than the 1/2, but that's how my brain sees it. And even when it's sticking off to the side like this, it's still going to be this base times this height cut in half. And so if you are familiar with the roots of where the formulas come from, you don't have to memorize a separate one every single time. The next one would be a parallelogram. What would our area be there? So, because it's a parallelogram, these are going to stay going the same direction flat. You can cut off this piece and fit it in like a puzzle over here. And it is again just the base times the height. So the other thing to remember with area is that we're interested in finding the area in squares. How many squares would it take to cover this area? And so as long as you've got a right angle, you can find area. That's what we're looking for. And so, I forgot to write this one in. Length times width is our rectangle. Half of that is going to be our triangle. Parallelogram, turn it into a rectangle. One that doesn't come up quite as much, but I have seen, is a kite or a diamond. So kite would look like this, diamond, rhombus would look like this. Rhombuses can also be treated like parallelograms. It depends on what dimensions they give you. But the other thing you can do, they're called diagonals. So you take diagonal 1 times diagonal 2. And again, it's half of the really big rectangle. So you just cut it in half. The one that trips people up the most, as far as I do not memorize this formula, is the trapezoid. They will throw trapezoids at you, and I don't memorize this formula either until I finally figured out what it meant. So the formula for trapezoid is this goofy 1/2 of base 1 plus base 2 times height. It's kind of weird. What's happening is trapezoids have one set of parallel sides. This 1/2 of base 1 plus base 2, that's the average. When you add something together and divide by how many things you have 2 lengths, and you're finding the average of those 2 lengths. That average is also called the mid-segment. You're finding the length of that middle. And all you're doing is chopping off these little triangles and turning it into a rectangle. And so that's how you can memorize that formula. Everything is about rectangles. Now, there are always a few people that absolutely hate this formula. Even after I show them where it comes from, they're like, I'm never going to remember that. So, the other thing you can do with area, sorry, board's getting a little full. The other thing you can do with area is to piece-wise. You can find the pieces. And so if you have a trapezoid and you're told that this bottom length is 12 and this top length is 5 and your height is 6. If you don't want to do 12 plus 5 divided by 2 times 6, what you can do instead is recognize that what I have is a rectangle plus a triangle made out of the leftovers. And so my rectangle is going to be 5 by 6. And my triangle is still going to be 6 tall, but this is going to be 5 taken away from the 12. To find out what's left over for this bit, you don't have to know how much belongs to each side. Back to that idea of it doesn't matter if you're just getting to the final destination. It doesn't matter if this is 3 and 4 or 2 and 5. Yeah. But if we have 12 and we take away the 5, we've got 7 left over. And so we're going to have 30 plus 6 times 7 is 42, cut in half is 21. And so with these areas, if you can find a way to remember how to get to your answer, that's what you need. So the area of a circle also goes back to this, but we're not going to work on that one right now. The bigger thing that I find with circles is that people have both formulas in their head and they can't remember which one goes with which. So we either have 2 pi r, some people learn it as diameter times pi. And we have pi r squared. Which one of those is the area?
Pi r squared.
Okay. Reason why you can remember it or help yourself know which one in your head. Because the pi tells you it's circles, but squared. Area is measured in squares. And so the one that has squared in the formula, that's the circle one. And here, whether you have 2 pi radius or diameter times radius, remember that 2 radiuses, that's what makes the diameter. And so it's really kind of arbitrary which one you use. Just be able to get to the other piece of information. If you know the radius, what's the diameter? If you know the diameter, what's the radius? Some people like this one because it's shorter. Some people like this one because it matches up with area and uses the same number. So that is our area and diameter. Oh, I left my phone. I had a picture on there that I wanted to use. Guess we won't do that problem. All right. So, couple different ones. I'm going to put them up both. Feel free to work on the first one as soon as I finish drawing it out. But they give us a drawing. We're in the coordinate plane. We have the point 0, 0, 10, 0, 3, 6, and 13, 6. And the question is, what's the area? Not sure why I threw a 2 on that. I meant question mark. First one, they just want the area of the whole figure. The second one, they want the area of the triangle. Even if you can't get a complete answer, go ahead and see what pieces of information you can parse out. What things do you know that might be useful for this problem? the ACT has the distinction of being something that is so universal. Lots and lots and lots of people take it. It has enough funding that they can get the best of the best. It is a truly good multiple choice test. If I tried to write a multiple choice test, I would be terrible at it. I understand my students so much better seeing their work in a different way. But the ACT is written so very well that with a multiple choice test, they can tell what students are understanding, what they're not understanding. And I tell people that if you are truly a math person, the ACT is telling math jokes. It's that moment of, oh, I got the clever thing. I'm delighted that I found this clever thing. This is fun. And so they're finding those people. They're also finding people that work really hard. The people who have studied and tried and practiced and all the things. Because if you think about college, those are the two ways to succeed. Some people are naturally brilliant and they think that this learning is super fun and they're just happy to be there. And some people work really super hard. And it doesn't matter if you think that it's fun or you're really hardworking, that's how you get answers. So, what's the easy one? How long is that side? 10. We know that the base is 10. And area's all about right angles, so we need the right angle. How tall is it? 6. And so what's our area? 60. Looks intimidating. Got all sorts of angles. You could think, oh, I have to do the Pythagorean theorem and find the slope. Nah. Just find the area. And it's just about the change in x and the change in y. And as long as you can focus on those without getting distracted by the other numbers, easy. One of the indications of how hard a question is, this was 38 on a test. It was over halfway. And so even if you get stuck on something, don't give it 10 minutes of your attention. There's going to be another question down the line that makes so much more sense to you. And so don't give something that's feeling difficult your attention for too long. I will tell you to fill in a bubble for 2 reasons. 1, guessing isn't penalized. And so absolutely you should fill in a guess. 2, if you leave it blank, you are so focused on solving and working, the chances of making the error, forgetting that blank, and filling in the wrong bubble go way up. And if all of your bubbles are off by 1, that's a terrible, terrible reason to do poorly on the ACT. And so give yourself the guess because it's a guess, but also because it's a placeholder. Don't let yourself get off on where you're putting your answers. Anyway, this one, a little bit trickier, but not much. How long is our base? Heard it?
6.
Yeah. So, on these mentally, in your book, a lot of times you're going to get a formula or an algorithm about how to get the answer, and it'll be something like x1 minus x2, all that. It's 3 away. It's 3 away. It's 6 long. Don't get too bogged down on that calculation stuff. The same way, how tall is it?
8.
Yeah, we've got 5 to the center and another 3 above that. So we have 8 in total. And so just like that one, now we have 6 times 8, 48, my brain. And what do we do with it? Cut in half. It's literally half that, just the same. And so we have 24 units squared. The one thing that the ACT is nice about, I have not yet seen it have a trick question about the labels. In fact, frequently the labels are included in the question and the answers themselves are just going to be numbers. And so this question would have asked, what is the area of the triangle in square units? And so the multiple choice would just say 24. And so there are times where units will catch you off guard on different tests. This tends not to be the one that catches you, and so that's kind of comforting to know. It's not going to be trying to trick you on units of, oh, it was supposed to be square units and you just said units, so it's wrong. Not going to show up for the ACT. All right. Both of those happen to be coordinate ones. There are other ones, but it gave me the chance to talk about coordinates as well. So this is problem 36. So again, it's kind of mid-test. We have the figure centered around X. And then we have a small circle inside of a larger circle. And we are drawing from X to Y and Y to Z. And so this is the picture they give you, but in the writing, they say the length of XY is 2 units and the length of XZ is 6 units. So what would be the very first thing you do for this problem? I'd be writing in numbers, because I am not great at holding things in my head. I want to write it down and move on to thinking about something else. And so the length of XY is 2, and I'm not going to even bother with the XZ. If XZ is 2, then this is 4. And that makes it really easy to write in. If the smaller circle is cut out of the larger circle, how much of the area in square units of the larger circle will remain? And so we have pi r squared, our first big circle minus small circle. I'm kind of visual on my notes. I'm not going to write anything out. It's just area of big circle minus the small circle. So our big circle was radius of 6. 6 squared is 36 pi minus small square or small circle radius squared 2 squared is 4 pi. What do you notice about what I wrote? I forgot to ask, who in here has taken geometry already? Okay, fair bit. Geometry and beyond, there's going to be a lot of leaving your answers in terms of pi. They acknowledge that it's a messy number, the decimals go on forever, and so it's much more elegant to just leave it as pi. And so 36 pi minus 4 pi is 32 pi. And so the answers, unless it's a real world problem of some sort, are frequently just going to be left in terms of the pi. And so all your multiple choices are just going to be there. And so you don't even have to enter the pi in your calculator. If you, for some reason, there are things more complicated than this, you just do the 36 minus the 4 and know that the pi was going to be there at the end. And so get familiar with leaving your answers not using 3.14 because they just use the pi symbol most of the time. All right. Back to our list. Use the properties of parallel lines to find the measure of an angle. So this one's going to come up a little bit later with other stuff. But again, for those of you who have taken geometry, what do you remember about parallel lines cut by a transversal? Even as a teacher, the thing that my brain goes to was there were all these properties about alternate interior angles and corresponding angles and alternate exterior angles. You don't have to know those. We're not doing proofs. There are a couple logic type problems on the ACT occasionally, but nothing in that proof structure. What you are going to use is called bow ties, and I named it so. So you've got two parallel lines, the transversal or the crossing line. All you need to know is that the bow ties are all going to be the same or supplementary. And so, in this picture, if we start with this angle being 50, the vertical angle is also 50. The corresponding or same spot in the other intersection is also going to be 50. And again, that vertical angle from the corresponding one is also 50. And so the reason I call them bow ties is because they look like this. Your bow ties should be facing the same direction. And if you again use that intuition, that understanding of math, it's all the small ones. It's supposed to be turned off. So all the small ones are going to be the same size. They're 50. And supplementary, meaning add up to 180, the straight line equals 180. So 180 minus 50 gives us 130 left over. And all of these are going to be 130. As long as you're familiar with that setup, that's all you need from parallel lines cut by a transversal. You're going to use it in conjunction with other angle stuff. There's very few problems that are just about that, but that's the only thing you need from parallel lines. You might see one that looks like this, where you have the two sets of parallel lines. I'm going to switch to the black. But again, all of these are going to be the same. And so as long as you can use that factoid, that's what you need. Right. Exhibit knowledge of basic angle properties and special sums of angle measures. So that's where we get into, angles in general. So we'll use this property, we'll use the vertical angles property, we'll use the fact that straight lines equal 180. All of those things combined together into angle problems. So one of the first ones, this was a problem number 6 on a test, so right as you're getting started, they give a quadrilateral or four-sided shape, and they tell you that this angle is 65, this is 100, this is 75, and they say, what's this one? So if you don't know this answer right away, the leading question to get to this is, do you remember what the angles of a triangle equal?
90.
Halfway there.
Just kidding.
So imagine a right triangle. This is one of the ones that helps me. We've already got 90 there. Do you remember what the other two equal?
45.
Together they're going to make a second right angle. And so they make 180 altogether for the angles of a triangle. If you take a paper triangle and tear the corners off, line them all up, they'll make a straight line. But the angles of a triangle equaling 180, that's one of those fundamental ideas that I want you to take into the ACT. that's one of the tools in the toolbox, you want to remember this one. Angles of a triangle equal 180, and straight lines also equal 180. Those are two of the building blocks that they use a lot. Now, from this, we have a quadrilateral, or a four-sided shape. It's just two triangles. And so this triangle equals 180, this triangle equals 180, the whole shape equals 360. And so once you have that fundamental thought, all you have to do is subtract 75 and 165. What's left over for that last corner?
120.
Okay. So, again, triangles equal 180, straight lines equal 180. That I would add to your short list of notes to know going into the ACT. All right. This one is really super wordy, so we're going to talk about translating ACT words. Which of the following lists gives two of the three interior angle measurements of a triangle for which the third angle measurement would equal one of the two given measurements? Yeah, so I'm going to write out our list and then we'll talk about that. So we have 20 and 40, we have 30 and 60, we have 40 and 100, we have 45 and 120, we have 50 and 60. So, triangle, we have learned as a three-sided shape, just because that's what we do in kindergarten. But the name literally means three angle. And so a triangle is going to be a three-angled shape. They have told us two of the angles, and there's a third angle that we don't know. And the idea is, if we know that the third angle measurement is equal to one of the two, which one makes a triangle? Which one would work? And so again, we're going back to that idea that triangles, angles equal 180. It's that fundamental thing. If we repeat 20, we have 20 plus 20 plus 40, that's only 80. We repeat 40, we have 20 plus 40 plus 40, that's still only 100. And so this one just isn't enough. Which one of those remaining ones would form a triangle where we have two angles the same and one different? 40 and 100, because we could have 40 and 40 and 100. And so that one is not a difficult problem. The difficulty is parsing out what on earth that language was saying. And so again, these multiple choice tests are very calculated to be testing all of the different types of math knowledge that might help you in college. In this case, this question, yes, it's using geometry, but it's a reading comprehension of math concepts question. And so going through that question again, it says, which of the following lists gives two of the three interior angle measurements of a triangle for which the third angle measurement would be equal to one of the two given measurements? And so if you can break that down into what it's talking about, that's what they were looking for on that question. All right, here we have three intersecting lines and then another line crossing, and we're told that M and N are parallel. There, don't give those arrows, but as I'm reading it, I'm marking in that's parallel. So parallel symbol is just two arrows going the same direction. And transversals R and S intersect to form an angle X. and the two other angles are as marked. What is the value of x? So the marked angles, we have 65 in this corner, and we have 100 in this corner. So the other thing that I feel like is unique to the geometry problems on the ACT is the ability to read down information. Geometry, more than anything else, is inclined to give you extra stuff going on that you don't really need. So, what is one thing that will be equal to our x? Yeah.
The vertical angle.
Yeah, in this case it actually is vertical because they're nice and up and down. So we have this one right here. And we've got this angle to work with. We've got this angle to work with. Is there anything going on with line N at all? No. And so, classic distractor. I wish you were allowed highlighters because I would highlight things so much if I were taking this test, but just cross it out, ignore it. It's not what we need. So, we have worked out, we've got a triangle to work with, and we've already moved our thing we're looking for inside of the triangle. So, how many people remember that there exists something called the remote exterior angle theorem? Good. Do you remember what it does?
It like is a supplementary angle to the interior one?
That one is the actual fact that we want. So I'll talk about that one in a second. But one of the things that, again, you learn this theorem in geometry, and it's technically a shortcut, but it takes too much brain power to remember it. Once you get past the geometry class, you're probably going to default to the way I'm showing you, and that's okay. So you are going with the idea of supplementary. Super easy, because we've got 100. What's this angle over here? 80. Great. Now, we know that the triangle adds up to 180. So 180 minus 80 minus 65, and find out what's left over for x. Pretty small. What is it? Yes. Sorry, I was trying to drop a 10 for a second. So, the remote exterior angle theorem has a slight shortcut that you could have started with just the 100 and subtracted 65 and gotten 35. But again, it's not worth the brain power to remember that unless you really loved it back when you did geometry. Otherwise, it's just easier to go with what you know and get to it. But you notice how here the thing we did was subtract that 80 right away. So that is a very classic problem. It is 17 on a test, relatively near the beginning. So being able to work with these angles, the idea that a triangle equals 180 and this vertical angle gets it into the triangle, those are basic geometry skills that I can't guarantee they'll be in the same problem together, but a triangle angle sum and a vertical angle are going to be somewhere on the ACT. It's just going to happen. It'll be mixed into another problem somewhere. All right. Ooh, we're almost out of time. Trying to pick out the best ones. Okay. On the short list, Pythagorean theorem. I'm going to talk about that one when we get to trigonometry, sine, cosine, and tangent, because they're frequently mixed together, but that one is also another one. So, locate points in the coordinate plane. I think you're good. Translate points up, down, left, and right in the coordinate plane. I think you're good there. Count the number of lines of symmetry in a geometric figure. I'm hoping that you can do that. I actually have not seen a problem doing that very much, but it's there. And use symmetry of isosceles triangles to find unknown side lengths or angle measures. So, just real quick, if they tell you something is isosceles, do you remember what that means? So, we have the equilateral, bad drawing aside, equilateral, equal line. And scalene means they're all different. Isosceles means that the two sides are the same. And the important thing is the instant they tell you isosceles, you're going to know that these two sides are the same, and also that the angles across from them are the same. And so that is something that you can do. If they tell you this is an isosceles triangle, it doesn't matter that they only told you one angle, because you know that the remaining angle has to be shared equally between the two of them. And so you'll take the 180 minus 50 is 130, and then cut it in half, gives us 65 and 65. And so just remembering that's what isosceles means, is that it has the two equal sides, and because of the equal sides, the equal angles. And so those are some of the tools that you can use again. All right. Recognize that real-world measurements are typically imprecise, and appropriate level of precision is related to the measuring device and procedure. Again, that's in the list. I have never seen a problem like that. Maybe with the new stuff that's going to happen, but experience-wise, I have not yet seen it. And so if you find one on your homework, tell me, I want to see it. So, compute the perimeter of composite geometric figures with unknown side lengths. Compute the area and circumference of circles. Given two sides of a right triangle, find the length of the third side. That'll be the Pythagorean theorem. All right. Determine the slope of a line from points or a graph. So I want to talk about slope for a second. How do I want to do this? What you learned in school, right? What does it mean? If I tell you that this is 2 and 7, and this is 8 and 15, what's going on with that formula? Or do you just plug it in the calculator and get something out? Okay. Mathematically, what subtraction or minus truly means is the change. When we say what's the difference, we mean what has changed from one to the other. And so this x2 minus x1 is talking about how much has y changed. Has it gone up, has it gone down, and how far? And x2 minus x1, again, we're talking about change. How much has x changed? So the mathematical notation for that, you'll probably see this in later classes. The Greek letter delta, looks like a triangle, means change. And so we're talking about the change in y, the change in x. And so the change in y in this case, we are going up, and we are looking at just the y coordinates. From 7 to 15, how far up? 8. And so our change in y is 8. Don't know what that is either. Weird noises. So change in x is our horizontal change. From 2 to 8, how far over? 6. And reducing down, our slope's 4/3. And so that understanding the change with the slope, so much easier, so much faster than the algorithm. The algorithm is what you would tell a computer. This is what you would tell a person. And I wish that teachers taught that better. So, the other thing to be aware of with slope, I know we're really close to almost being done, parallel and perpendicular. Something you learn the 3rd chapter of geometry and then it gets tossed again. Parallel, how, in terms of slope, would you have parallel lines? Yeah?
Their slope is the same.
Their slope is the same because they're moving the same way. They never cross each other. They move the exact same. Their slope is the same. So parallel. Parallel is going to be the same slope. Perpendicular, or meeting at right angles, you have to change 2 things. One is that you flip the slope upside down, called the reciprocal, but we're not interested in math words right now, we're interested in results. So you need to flip fraction, and you need to change the sign. And so with our 4/3 slope here, if we wanted to go perpendicular to that, we'd flip it upside down to 3/4, but 3/4 would still be up 3/4, really not perpendicular. What we need is negative 3/4, and so if we go down 3/4, that would create our perpendicular. All right, we are done. Thank you for a great lesson. I don't know when I'm back. I need to look at my calculator, but you'll see me again. All right.